Whether you're getting pulled up the lift, launched out of the station, or playing forbidden jump rope on an aircraft carrier, wire ropes make the amusement industry work. Let's talk about it.
Now get ready. Here we go.
Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? Alright, today's video I wanted to talk about steel cables, wire ropes. They're known as many things, but pretty much for this video I'm going to either refer to them as cables or wire ropes because that's how we generally talk about them. So the first question is, what are cables and wire ropes used for? Basically, cables and wire ropes are used for power transmission. Anytime we need to take power from somewhere and move it to somewhere else, we typically use cables and wire ropes for this installation because most other things just don't work well. If you think I need to move one side up while moving another side down, you can build a giant steel plate in like a triangle and let it tip from side to side and connects one side to a big hydraulic cylinder. Or you could just take that hydraulic cylinder, tuck it somewhere nice and neat and out of the way, and then just run a cable from it around a pulley back to the other side. It works much easier. You can get more things happening in a smaller amount of space, and for places like Disney and Universal, a lot of amusement parks really, you can hide movement by putting cables inside of them and moving things around that way. If this is your first time here, please make sure you like, subscribe to the channel. I put these videos out all the time. I try to make it once a week. I'm pretty good about doing that. I'm always looking to grow the channel, so like, subscribe, share the video. It does help me out, and I do appreciate it. Alright, so where would these steel cables be used? Well, let's talk about some scenarios of where they're used and why you wouldn't really want to use something else. So the first one that comes to mind, probably in most of your heads right now, is a hydraulic launch. The hydraulic launch rides, typically, most of them are made by Intamin. All of them made by Intamin? I'm not sure about that one. Does anybody else make a hydraulic launch ride? No, I don't think they do. I think it's pretty much just Intamin's hydraulic launch rides. Anyways, what they use on there is two steel cables holding on to a trolley or a launch car in the center, basically, and they take that car, that sled, and they pull it down the track really fast with both those steel cables as they wrap up around a big steel drum at the end of the track. So why couldn't we use a hydraulic ram, like a big hydraulic cylinder, instead? Well, you would need a cylinder that extends the full length of the launch. I don't remember what the launch is. Let's just say it's 200 feet. I don't remember what it is off the top of my head. But you would need a 200-foot long cylinder to extend. And you would need that cylinder to extend 200 feet further past. So now you need a space that's 400 feet long. You would need the weight of that cylinder supported all on one side. Typically the ram is not supported at the end. It doesn't have a place to go into. So all that weight would have to cantilever off the front, which means that you would need a giant support system for that ram at the front of it. Now, that would probably be about 40 or 50 feet by itself. So now you're talking about 450 feet. As the ram extends, the amount of hydraulic fluid necessary to push that ram out there would be ridiculously large as compared to what Intamin was able to build for the ride. So the fluid usage is not really useful. I mean, the power package is not big enough to supply all that fluid. Not to mention, the mass of that ram extending would be so great that it would be like trying to launch 6 roller coasters at the same time. So it doesn't work. So they use these, in comparison, they use these really tiny, little tiny steel cables to launch the ride. Do this example early off, right? This, I went to the hardware store and picked this up. This is steel cable. This is wire rope, essentially. This is what is used all over equipment, just in a little bit bigger. This stuff I bought for home use, so it actually has a nice plastic sheathing on the outside, so it's easy to slide through the fingers. But in the center, right there, is the steel cable core, which you could actually also see through the clear plastic. This I bought for another project. This is also steel cable. It's the exact same thing, but it's got no sheathing on it. So this is just the raw cable by itself. And I'll go into construction of this in just a little bit. But that's pretty much what it is right there. So what I'm talking about, like this is only about a millimeter and a half, maybe 2 millimeters wide. It's not much. This guy right over here that I first picked up, this cable's about 4, maybe 5 millimeters wide. The ones on rides, typically, small cables on a ride start around the 16 millimeter mark. And they move up to the 20 millimeter mark and a little bit bigger, 22 millimeters, somewhere right around there. Launch coasters probably use, I don't have personal experience with it, but it's looking like they use probably around a 24 or 26 millimeter cable on both sides of that. And remember, there's 3, 2 for the launch and 1 for the return out the back. All right, sorry, tangent there, I know. I liked steel rope. It was a good topic. Way back when I took a Ames inspection class on wire rope, and it really gave me a lot of like, wow, that was really cool. I came back to work with a lot of knowledge, a lot more knowledge on that wire rope inspection. So that was a pretty cool class to take. The next place where wire rope is commonly used, you'll see it at the amusement park and be like, there it is for sure. Your classic boomerangs. Now, classic, I mean by like the original style boomerang, and then we can go up to the rare, but they still make them, the rare giant inverted boomerangs, the GIBs. The GIBs also use cables up and down both lifts. The original boomerang only used a cable on lift number 1. All right, so for the boomerang, is there a better way to do that? Can we do that with a hydraulic ram? Well, if you think about a boomerang at a start, it takes the train from the horizontal position and then starts lifting it up at about I believe it's about a 55-degree angle. Well, there's no type of mounting of the ram inside that area you could use to get that range of motion. You could either do straight line from the top to the horizontal position, or that's pretty much it. And it's not really a good range. So no, you pretty much have to use a cable. So you put a cable up the lift 1, curve it around the top, and come back down to a ram. And again, you're talking the same thing. If the lift is 100 feet in length, then you still need a ram that's 200 feet long to collapse down to the 100 feet in length. Not great. And then you have all those other problems. Rams like to kink when they're extended all the way out with each other. They like to kink in the center when they get under pressure if they're under a pushing load. Pulling, not so bad, but it's not a great scenario. Okay, so I think you get the idea of why cables are starting to become necessary, because you can just move them and connect them in ways where it's like, yeah, that just makes more sense. It starts making the ride a smaller package, and then you can do things like get them in a nice little wound up area where you don't have these huge components sitting. So let's go into other places where cables would be used. First one that comes to mind, an air launch. At Six Flags Great America, it is a giant steel tube underneath the track, essentially with a piston on the inside. It's got a cable that wraps around from that piston, and it goes all the way up and over the top and connects to the sled at the top of the thing. Now it also has, kind of like a hydraulic launch ride, it also has a cable behind it that comes back around and returns underneath that exact same piston. As the piston goes forward, the sled moves backwards, vice versa. So the nice part about that is that S&S is actually able to seal around that steel cable, which I don't know if you look at it, like sealing this in the raw form is not the easiest thing to do, but S&S has a pretty good way of doing it. Now, that is also the exact same technology and pieces, I should say, that they use in their Tower Powers as well. Same exact thing. If you know how Tower Power works, you turn it on its side, and you've got max force at that point. It's the same exact thing. Scream and swing, while we're on the same thing. Scream and swing. It's max force, tower power, scream and swing also. Same exact thing. Instead of just the cab there, it wraps around the top in the center section, and you get swinging motion from the seats. I mean, realistically, the S&S stuff was kind of like they figured out one pneumatic power package that worked for them, and they kept going with it. Another place that uses those steel cables, good old Anton Schwarzkopf. Oh man, that guy was great at using steel cables. For his 2 iconic machines, the original shuttle loop with the big weight on the far tower, that shuttle loop had a massive steel cable that ran back to the counterweight, and then it had another set of steel cable that would actually attach to the launch, the pusher car out there. That pusher car that would get underneath the roller coaster and push the thing. That was its revision 1. Then remember revision 2, they changed that whole assembly out. They got rid of the counterweight, and they just had the flywheel at the end. And that flywheel was also connected to the same exact steel cable that the weight drop used. So another steel cable inside that machine as well. We move into things like fair rides. Fair rides do use cables all the time. You have things like the swing ride, where it would like lift you up the tower as the swings would rotate, like a Sky Screamer, Starflyer type ride from Fun Time, like one of those. So you'd have rides like that, but then on the smaller rides for fairs, and this happens all over the place, since the columns and everything are put up with linch pins in place, and they use these pins that they stick in there, put an R-clip on it. Those aren't the tightest fitting assembly. So what they do is, as they put those things up, they put steel cables onto the corner of things, and they stretch them tight. And then that creates another structure, and it reinforces the first one. On rides like the Zipper, which I know they just recently had an accident on one of those Zippers, between each one of the set of gondolas, each cabs, whatever you want to call them. Anyways, between those, there are cables put in an X fashion in there to keep the actual cables, more cables, the cables that drive the Zipper around. They use an X-brace type cable in the middle of those cables to keep those things synced up with each other. If I got that right, I'm pretty sure the Zippers use a cable going around the outside of them on both sides. Fairly certain. Okay, next up, a little bit less, but they're still out there. They're still in use. Sky coasters. You know, the big ride that looks like a giant tower at the front, and you put people into, it looks like a overgrown sleeping bag, and then you pull them up to the back and then let them go and they swing out. All right, sky coasters are nothing but cables. There's a steel tower in the front, a steel tower in the back, and then the rest of that is cables. It is actually made up of 4 cables, kind of. People that know sky coasters well, again, they're like, that's bull. It's not 4 cables, but hear me out. I'm not trying to get nitty gritty for everyone at home. I know they're probably already lost in this video, but you have the 2 main cables that come down to where the rider is or the passengers are. Those are your flight cables. You have 2 of them. Then down the back, right in the center, you have another cable that hangs down. That is your counterweight cable that attaches to a launch bridle. The launch bridle is the one where people are like, that's 3 cables by itself. It's like, calm down. And then you have the launch cable, which comes back and is attached to that launch bridle. So you have kind of like this weird looking upside down triangle that makes up that rear assembly. The launch cable goes up and over the back tower, comes down to a hydraulic drum assembly where it winds the cable up. When that cable winds up, it starts pulling the people back up the back towers. And then you undo the launch bridle from the passenger harness and the people go free. Let me know if you want to see a video on sky coasters. They're really not that complex, so I don't think that would be a long video. Anyways. Sorry if I seem a little spacey here. I'm just kind of like either getting a cold or getting over a cold. I'm not sure which one it is, but something's going on. It's kind of making me a little disconnected today. The last one that we're going to talk about, they're kind of cables, so I'm going to put them in this, but I mean, this is a vast topic by itself. So I'm just going to barely graze the top of this topic, just ever so slightly. Push-pull cables. Push-pull cables are used on a lot of restraints. Now, this was mainly restraints before they went to hydraulic style restraints. But for your older B&M coasters that still have ratchet assemblies on them, a lot of coasters like that, they use cables to lock and unlock those restraints, and those are called push-pull cables. So, yep, those are a type of cable as well. Push-pull cable, all it is essentially, it's basically a steel rope that's in a sheathing that is extremely stiff, just like that. So what you have here is that, think about it like this. This is a push-pull cable. It's in a sheathing, so you can pull it down and you can push it up. Pull it down, go up, and I can get it to hit things and push things and pull things. This, unlike a normal cable, like if this is my normal cable, I can't push things with this. It doesn't work. Push-pull cables, however, they have a Viagra complex, and they are allowed to actually very rigidly push on things, and then they could pull them back down, and then you could push them back up again. So that's basically the main difference with a push-pull cable. Okay, construction of a wire rope. Where do we start with the construction of a wire rope? Well, we're going to start in the center of the wire rope. The center is called the center wire. It's basically one single strand that goes through the entire rope, and that center strand can be made out of different things. So it could be a piece of steel, whether it be stainless steel, whether it be galvanized, whether it be aluminum, like rope is made, or steel rope cable is made in all sorts of different materials for every aspect of anything you could think of. So you name the combination, it's out there. The original SNS power tower, people told me, I say, oh, that's a, what did they say that was? The employees that were out there, they said it was a composite rope. That's what I was looking for. But they said basically it was a different style rope. It wasn't, they're like, no, it's not a steel rope, it's something else. And I was like, that's weird. So I went home and I started Googling it. I'm like, do they make this in anything else? I think they were confused on it because the steel rope subject is a very large subject. It's kind of confusing, honestly. So when it comes to the center wire, you can replace it with other things, in which case, like a lot of bigger equipment, they replace it actually with like nylon, like plastic on the inside. Not only plastic or nylon, but they actually impregnate it with graphite and things like that. So as the rope goes over pulleys and through sheaves and stuff like that, it actually lubricates its strands from the inside out. Pretty cool, right? But yeah, so that's the thing. I think that's what they were talking about. That center was probably a plastic piece of material on that. I don't think the rope itself is just a steel rope. That's all it is on those SNS Tower Powers. And I've had people confirm that. They're like, yeah, it's just a regular steel rope. Around that center is what are called wires. The wires are the actual pieces that you could see on the outside. If I show you this, try to do this where hopefully I can zoom in on it. These little pieces that you see rotating around in this very uniform fashion, those are actually the wires that are wrapping around there. But those wires are actually put together in a strand. So you have wires wrapped around into a strand. The strands are wrapped around into the rope. Did I miss you? Okay, all right. I don't know if I can undo this. Can I undo this? Oh, I can. Check that out. Let's see if we can do this. Let's see if I can get this. I might be able to show you this, might not. Okay, right here you have, if you look at it really carefully, you can't see the center wire in here, but the big bundle that I'm holding, that is the rope. This is the rope right here that I'm holding. Now, the piece that's stuck off to the side are the strands. Okay, so you have the rope, the big piece, and then strands. A bunch of strands wrap around each other to make the rope. But in those strands right there, in that little tiny piece, are a bunch of individual wires that wrap around each other. So it's really kind of weird to think of. If you look at this guy, you take a bunch of wires. If you think of this as a wire, I'm going to take a bunch of these and wrap them around each other. If I took 5 of these and wrapped them around each other, those are individual wires, which are solid. I took wires, wrapped them around each other, and then I made a strand. And then if I took that strand of those wires and wrapped them, that strands around each other, I now have a rope. Different configurations of that. There are different amount of wires, different amount of strands, different amounts of everything that goes into those. You could keep repeating the process. You can keep doing it over and over and over again. So you make all sorts of patterns out of this thing. All of them end up with variable lifting capabilities. Okay, so when it comes to the lifting capabilities, there are 2 types of lifting capabilities out there. This standard wire rope right here. This stuff you find at hardware stores. It's nothing amazing. This is what you would call just your standard right lay wire rope or cable. Standard right lay steel cable wire rope. Okay? By right, I mean like if you look down it, all the strands basically go to the right. From the way I'm looking at it right now, it's basically going clockwise to the right as it goes around. Do they make things other way? Yes, they do. They make left lay cables as well, where if I look down this exact same piece, those cables would go to the left lay. Now that's the lay of the cable in there. There is also how much they go around. Like you took all these wires, got them into strands, put them together and made the rope. Well, if you just took a F-ton of strands and kind of just laid them all together with each other without actually turning them individually and just kind of wrapped them all around themselves, you get this other rope that's called Langley cable. Langley cable is really interesting stuff. It is made to go over pulleys at a sharper radius at a higher speed. They're also, I believe, not sure on this one, I'm pulling stuff off the top of my head from a long time ago. I believe the Langley cables have a stronger capacity to them as well. But they don't last as long because they're not wrapped nice and tight with each other. They kind of just sit there. They don't last as long. But where we find a Langley cable? Well, you find Langley cables inside of elevators. That's the number one place they're used, is inside of elevators. Things that have to move really quick in a tight radius, you pretty much have Langley cable inside of there. They're replaced more often. They're less forgiving for sure. They're not, basically, the safety rating on that is that they're not as high as like a traditional steel rope cable is. Now, I'm sure I will get plenty of people that say, no, they're higher, no, they're lower. Like, not the point. Anyways, there's right lay, left lay, and there's Langley style cables in both the left and right as well. One of the interesting places I found a Langley cables was actually inside of the S&S, basically the, what do they call them, the scream and swing. The swings that they make, basically one side, the top side going into the cylinder is just your standard right lay cable. Cool, goes right in the top. The other right lay cable comes down inside the assembly, turns around, but before it turns around, it actually turns into two more cables. Those two more cables it turns into are actually a left lay Langley and a right lay Langley cable that go around a bottom sheave to go back into the cylinder on the bottom of the thing. And I thought that was like, wow, that is really complicated to do, especially since they don't do it on the top. But putting the left and right Langleys opposing each other would keep the thing from twisting and rotating, because that's one thing cables do when they get under tension. They naturally want to twist. They naturally want to try to essentially unwind. So there's a bit of that you have to do once you put a cable up on something. You have to let it sit there and do what we call relaxing. We have to relax the cable for a little bit and just let it sit there. Anyone who's worked on a sky coaster knows this. You have to go up to the flight line every day and you have to disconnect the cables and just let them sit there and hang from the tower, just because it's like, what are they doing? Well, they're relaxing. Oh, isn't that nice? It's like, yeah, it's nice to have relaxed cables. It's awesome. But basically what it did is the previous day, that cable stretched just a little tiny bit. When it stretches, it starts to twist. So you undo the cables and let them go. And that little bit of stretching, the cables will actually start to turn a little bit, and then they'll relax and they'll find their center again. Then you connect them back up, ready for the next day. Okay, moving on. How are wire ropes inspected? Well, wire ropes are inspected like this. This one's good. Yeah, kind of jokingly, but also kind of serious. So a lot of rides use spools and drums to actually wind up wire rope on. So wire rope's typically done like for a Boomerang, for a sky coaster, almost anything. Wire rope is done in 2 inspections. You take whatever it is all the way to the top. And then you say, okay, I've got this all the way to the top. And then you go to your drum. Your drum has all the cable sitting on it, like this. And then while it's sitting there, you can look at almost all the cables sitting on that drum and you could say, yep, it's good. You can even move the drum just a hair to look at the other side. And you could look at that and say, yep, that's all good. Then you have to bring it all the way back down to the bottom. And now comes the hard part. You have to manually inspect the cable on the other side. Like for a boomerang, this is where once the catch wagon's all the way down, well, you now have to walk up lift 1. And you now have to look at that cable going all the way up. Because the cable that is now on top of that lift is the stuff that was above the drum that you couldn't see from the ground. So now that thing that was above the drum that you couldn't see from the ground is now draped across the top of the track nicely, and you could just climb up there and look at it very carefully. One of the easiest things to do is to wrap something around the cable to check for a failure inside the cable, essentially. We'll get to that in just a second. What type of failures do you have inside of cables? Okay, so there's a handful of wire rope issues that you're going to run into. They aren't very crazy when it comes to finding them. So the first one is actually your most catastrophic. That's going to be a broken rope. Remember, that's your rope, right? So the whole thing is just on the ground. It's broken. It's in 2 pieces. It's like, I'm not a technical guy, but that's your problem right there, boss. The rope ain't roping at all. All right, that's the first one. The second one you're going to come across is going to be broken strands or broken wires. Broken strands are really easy to spot because they make a mess on the rope. Basically, as you look down, if you come across broken strands, it'll look like this big mess right there around the cable. That mess actually has a name. It's called bird caging. So it's rope's bird cage for 2 reasons. One is broken strands, and you see all the strands out and about in each other. The other reason they bird cage is because the strands are broken internally, and it's like the rope is trying to unravel, and it's trying to open up from the inside. And the rope strands come apart like this, and it creates like this bird cage looking thing. Either way, you have strands broken. Remember, you have your center wire. You can have broken wires that make up a strand, and you can have broken strands which make up a bunch of strands together will make up your cable. One of the other things that is the first sign of failure that you look for, that is the one that most mechanics are trying to find, is the broken wire. Now, not the rope, not the strand, but the wire itself. Just one little tiny wire broken. Now, how do we find broken wires in this mess? And it's like, well, actually, they're really easy. When wires break, they tend to actually stick out just like that. Just like that. I wasn't even trying for that. They come out just like this. Because what happens is that this entire assembly, the entire set of strands that make up the rope, they're all under tension. They're evenly being pulled. Think of it kind of like a Chinese finger trap. You remember those things? You put your fingers in, try to pull apart, and it squeezes your fingers on both sides. It's like they do that all the way around. So when you break one strand, it loses that tension, and it's got nothing to do. So most of the time, it just pops right out, and it's got nothing to do. It just starts hanging off the rope. It's like, cool. Can you see that? Sometimes you can, sometimes you can't. So what do? You take a rag, and you actually tie it around the wire, and you basically make it like a loop, essentially. Had to go outside and get shop rag. Here we go. All right, so on this guy right here, you're going to take this shop rag, and essentially you're going to turn it into, kind of like wind it up a little bit, and you're basically going to turn it into a loop, just like this, where you kind of see right here through the center, like that. And you pull that around the cable. Up is going to be easier for me, so I'm going to do this demonstration like this. Take it around the cable, and then you just hold on to it, and you just pull the cable through it. Like that. If the rag grabs, there's probably something in that area. Now, cables that are in really nasty areas, they can get little pieces of wood like branches and stuff that birds land on it. A lot of cables like the boomerangs, they are greasy. Greasy not so much in a slick manner, but like in a cable grease manner, which is quite tacky. So a lot of times you have to put a lot of friction on this rag and really hold it tight as the cable pulls through there, because you're actually spreading that grease back around in that area. So for the Sky Coasters, they did not want that. So the Sky Coasters, they run their cables with no lubrication on them at all, because they're just hanging there. So Sky Coasters don't need lubrication on the cables. So Sky Coaster wants you to very finite. They want you to very finite feel like, is there anything wrong with this cable whatsoever? Well, a big problem with taking my hand like this and saying I'm going to feel for a cable, like I'm going to feel for a little wire poking out of here somewhere, is that eventually when I find this, there's a really good chance that wire is going to go right into my thumb or my finger and come out the other side. They're really good when they break at turning into basically like hypodermic needles. Yeah, they go straight through your skin, right out the other side. It hurts, and then you can get an infection, all sorts of other stuff. So the Sky Coaster's manual actually says, they say, you know what, you could take a rag and go around it and do this, but they actually say that this rag might not actually catch the imperfections. The imperfections might slide right through that rag like there wasn't a problem. So they're kind of paranoid about it. So they said get something finer than a rag. They said get pantyhose. Get pantyhose and wrap it around and do the exact same inspection, because the pantyhose are fine enough that if there's any problem whatsoever, it will snag and it will pull that out of there. So that was always an interesting thing with the Sky Coaster. Always one of my big jokes I always joke around. Hey, what's your part number for pantyhose? Do you guys have that? Because I don't know what part number that it is, and we're trying to order it right now. Do you have taupe?
Namaste.
Excuse me.
Yes, sir.
Do you have any of these in taupe?
Anyway, so looking for broken strands, broken wires, and that sort of stuff is a very big part of wire rope inspection. So what's the next part of my inspection? Well, yeah, these are little wire ropes, every single one of them. Every single one. Am I trying to tune this? What am I going for here? Tension. Tension is what I'm looking at. Okay, so just like this guitar, these cables tension properly will produce the correct notes across them, okay? If I over-tension one of them, there's a chance it could break. So that's when you run into something like a pulley that's not turning, or if something is caught or snagged somewhere, it'll break off of there. But what you don't typically have is on the other side of this guitar, where the bridges and everything, all the tuning head is up here, you're typically not connecting two strings to the same thing that has to move. Well, we do that all the time with amusement rides. Amusement rides, we will take two or more cables and connect them to one device and then wrap them around a drum. So we have to put an even amount of tension on both of those cables, because one cable can handle, let's say, 15,000 pounds of pull strength. So you put two of them together, you have 30,000 pounds of pull strength, which is no problem because you're only pulling 10,000 pounds on the other side. But if one of my cables goes slack and the other one stays tight, now instead of it only pulling 5,000 pounds apiece, now one is pulling 10,000 pounds and the other one is pulling nothing, which is a big problem because whatever it's pulling is also now crooked because you're only pulling it from one side. Sometimes we do things like hydraulic launch rides. Any sort of launch type ride, whether it be hydraulic, pneumatic. Let's see, there's the one that Disney and Vekoma built, Paris Space Mountain, I think it is. Anyways, there's a couple of them like this where they use a sled and linear induction motors to pull the ride up. Well, the sled's actually being pulled by steel cables on the other side that are wrapped around the thing. And then what's more complex is rides that lift and spin, things like tower rides. The Star Flyer, we used 6 cables on that supported the star. I know there's the other one that's out there that uses even more cables than that. The Windseeker. Who makes the Windseeker? I don't remember who makes the Windseeker. Anyways, the Windseeker, it uses a whole bunch of cables on it as well. So what you have to worry about there is that not just one cable is way off, that all the cables are just slightly off. So you have to use a cable tensioner gauge in order to check the tension on those. Now, how do you do that? So we take our steel cable, just like this, and we hold it, and you essentially put it between two places like this, and then you push the center over and you bend it. And that deflection is measured. It's a very precise strain gauge tool that's put on there. Basically, you take 3 points in the center, you push on that cable, and the tighter that cable is, the harder it is to actually move that cable over. So like right now there's no tension on this and I could pretty much make a U out of it, no big deal. If this were supporting 1,000 pounds, I would only be able to move it just a hair. Just a hair. And that's what those gauges are actually meant to do. They're meant to tell you how much tension is on that cable by how much it moves. That way, whatever the tension is doesn't really matter. You can actually go through and tension all the cables the exact same way. Okay, so how are cables mounted to stuff? You can't just take this cable, put it on something, and hammer and nail it inside there. It doesn't work that way. So there's a couple different methods of the way these things mount. The first one, and the most commonly used, is what's called a thimble and clamp. So typically you take these little clamps. It's a U-bolt. The U-bolt right here in the center is actually the clamp. This cast piece that's on the outside is called the saddle. And then you make an opening right there. You put this guy through it. I don't have a thimble right now on me, but basically you take this guy back around here and you put that through there, just like that, and then you tighten the nuts down. This is kind of hard to do. Done this before, you know, it's a little tricky sometimes making things move, but not while you're making a YouTube video. It gets a lot harder. They're typically done in series. You get 2 of them. So I'll redo this. And I'll give you guys a test now. For those of you that always say, I want to do this stuff, I want to do this stuff. You get a test. Some people will laugh, some might spit out their coffee. But here's your test you're going to get. And if you're a wire rope person, I'm sure I'm going to get a comment that's a mile long out of this, but whatever. It's fine. All right. Here it is. All right. See those 2 guys? Notice one's installed. I'm going to put it this way. One's installed the correct way. One's installed upside down. Any idea? Any idea? The term that a lot of people have heard out there, but a lot of people don't really maybe understand what it is called never saddle a dead horse. I'm going to explain why that is. Okay, so remember as I was talking about these clamps, one piece was called the saddle. The saddle is that little cast piece that sits right there, like right there is on the top. That's the saddle right there, okay? This piece, the tail that comes out, is typically just referred to as the tail of cable that sticks out the end. The way that they try to get people to remember to do this, they say never saddle a dead horse. The tail in this case is referred to as your dead horse. It's not holding the load. When I support this like this, what's happening is that from here all the way down through here, this cable is supporting the load. So therefore this is done correctly. The saddle is on the load cable. This saddle is on the dead cable, the tail, dead cable, tail. So they call this the dead horse. So this is your dead cable, the tail, and I have put a saddle on it. Now I know a lot of people are like, who cares? Get on with the video, Ryan. This is very important because when you tighten these guys down, the saddle takes the load of the cable.
That's what she said.
And disperses it evenly. So you can tighten the assembly together and you won't have a problem. It stays there. The bolt, on the other hand, in this case, the bolt puts a pinch load onto the cable. Ryan, you're drawing this video out too much. Shut up. Get on with it. Okay. When you put a pinch load on your live end of the cable, you have now effectively reduced the diameter of this cable down. So if I could hold 6,000 pounds with this cable right now the way it is, as soon as I tighten this bolt down where it puts that crimp onto the live load side, this cable can now only hold 3,000 pounds because this bolt is damaging this cable. But when these two are done correctly, and the saddles are both on the live side of the cable and the dead side has the bolt on them or the clip on them, when it's done correctly, you put 3 of them in a row, typically general standard, and then that whole assembly is good for the entire length of that cable. And the thimble eyelet, I've got some here for the smaller cable kit. These guys right here, These guys, I know this is way out of proportion, they go up in the center around like that. The other style is a swedge. This is a swedge right here. I call it a swedge. Basically, this little cable goes through like that. Now we take our eyelet that we have, we put this back around on itself right here, because I already took this apart. It's not going to be great. Look, right into my skin. Man, that's just wonderful. All right, then we put that little eyelet right there, eyelet inside of here. I don't know if you guys can see this. I'm just wasting my breath. I'm sorry. Pull this up. Now, this isn't the tightest because I don't have it hooked up to where... Okay, and now that's the cable end right there. It's got a nice eyelet in it, and it's got a nice little swedge or crimp in there. And now I can use, I don't have a pair with me, but I use a special pair of tools to basically crush this on both sides and squeeze it shut. Because the whole thing is deforming and clamping around the cable, it doesn't do like the dead horse scenario where it puts a bind onto one side, so it evenly squishes both cables together to where there's no loss in the integrity of the cable. Common ways that cables are mounted to drums is typically either a double bolt clamp that's right on the drum, and the way that works, the clamp is not actually holding the cable. The clamp is just putting a little bit of pressure on the edge of the cable. The cable typically has to be wrapped around the drum a couple of times. That is what is holding the cable. Unlike a boomerang, the cable actually goes through the drum and it puts a wedge inside that drum. That wedge holds the cable in, and you could put a lot of pressure on that wedge and pull it into that drum and it will not come out of there. But that's not what's doing the lifting on that boomerang lift drum. It's actually 3 wraps around the drum of that cable. Those 3 wraps around, that is what is doing all the lifting in there. There's also one that's less commonly used, but I believe possibly, I'm not sure, on the Intamin rides where they're using the cable on lift hill, like a Sky Rush, something like that. It is a swedge and locking liquid. Basically, it's called a spelter. Spelter? I believe it's spelter. That is where you take this cable, as I've already done here. That's where you take this cable and you put it through this little tiny hoop and eye looking deal. And all you do is you essentially take that cable end and you essentially unfray it. You start to untwist it and make it to where it looks like a bird's nest on the end. And then you try to pull it back through. Because it's now not that same diameter, and that's a pretty precise piece, it's all frayed out. It now will not go back through that opening. It's essentially mechanically stuck. And then you take that opening and you could do things like pour a chemical bonding agent on the inside, which is kind of like epoxy. Pour that on the inside to freeze those cables that way. Some places actually use like a solder. They dump like a melted metal type solder inside of that spelter, I'm probably saying that wrong. And it locks the cable in that way too. Those, I believe, are the ones that are used on those Intamin lift hills. Man, this is going to be a long video, I'm sorry. So the last topic that I wanted to cover on this, it's one I have the least experience with because I just never had to deal with it. So, but I know of it. It's called cable splicing or a cable marriage. Now, there are ways to take these cables and put them together without using any of these components. And that way is called a splice or a cable marriage. Any idea where that might be done on a regular basis at some amusement parks? Well, outside of an amusement park for sure. Think about it. You ever go on an aerial tramway, buckets, sky ride, anything like that? Okay. How many cables do you think are on that skyway? Any idea? Because you could put a lot of cable on a spool and ship it out. But either way, the cable is just like this one. It comes with 2 ends. Think about your sky ride. Does it have 2 ends on that cable? It does. Do you see them? You don't. Is there equipment holding it together? No. It's called a splice or a cable marriage. It's an incredibly complex thing to do. It's not something that any old crew can just go out there and just like, we're going to go splice that cable together today. Very complex. I'll give you a for instance. I'll read this here. In Palm Springs, California, the aerial tramway is 2.5 miles long. That's 26,000 feet or 8,000 meters. How big is a spool of rope 40 millimeters in diameter at 8,000 meters long. Any idea? The general estimate is that that's going to need 8 spools, which means it has 16 open ends. Now, when you get on that aerial tramway and ride it, you look up there. How many cables are up there? Is that one cable? No, actually, you're looking at roughly 8 cables up there. You don't see it, but they're there. So again, this is the topic I have the least amount of information on, so bear with me on this one. So rope splicing, or as I was taught, it's called a marriage. The rope marriage is done by you take a rope at both ends. Now there's a formula for it. It's actually, when they take the ends, they have to measure back a length that is equal to or greater than 1,200 times the nominal diameter of the rope. For example, a 45 millimeter diameter rope means that the total length must be 54 meters. It's got to be 54 meters in length. So what they do is they take this rope and they start undoing the strands. And they start undoing wires in there too. They completely, basically bird cage the ends of both cables. At special frequencies and certain distances, they go into there and they take those wires and strands and they cut them. They'll take the wires and they'll cut them off at different lengths. And then the other end, they make the mirror image of it and they cut those off at different lengths. They open up the cable a little bit more, bird cage it, and then they'll take a wire from cable A and the bird cage in cable B and insert the wire into cable B. And then they'll keep doing that. They'll keep opening up the wires in cable B and cable A, and they'll basically interlace the two with each other like this. Now, that Chinese finger trap, like I was talking about earlier, those things overlap with each other, and it becomes thick. But the way cable marriages are, they don't become thick. They're done in such a manner where material's removed and they're put in that when they are done and they are put together, they can only be 10% larger than what the original cable was. So, to the bare naked eye, if you're looking at a 45 millimeter diameter cable that's only that big around, and you're looking at it up close, so you're, let's say, 15 feet away from it, well, that 45 millimeter cable up there is going to be 49.5 millimeters, 50 millimeters at its max. Do you think you could spot a 5 millimeter difference on that cable? I can't. I've sat there for a while and tried looking for one of those splices. I could not find them. And I know I probably saw a bunch go right by my face and I could not find a splice in those cables. But that's kind of interesting to think. Next time you're going up an aerial tramway, whether it be across an amusement park or up the side of a hill, just look out over all that distance and say, wow, there is a bunch of individual cables laced together with nothing holding them whatsoever other than friction. That's it. Friction is holding that whole thing together. And the guy who used to do aerial tramways, which is also a state inspector, because California, it's amusement rides and aerial tramways, he was saying that the cable marriage, when it's done properly, is like, it was something like 1.5 or 1 in 3, almost 2 times as strong as the cable. So it's not a weak spot at all. It's actually stronger than the cable itself once you put those 2 cables together and you can't see them. That's pretty incredible, isn't it? Wire ropes always kind of fascinate. All right, I've probably left out so much from this video. I apologize for maybe some simple stuff that I left out, and like when I release the video, I'm going to get comments and I'm just going to be like, I didn't cover that. Oh my gosh. But sitting here now, it's like, oh man, I'm looking at my time. I'm like, oh man, I've been talking for pretty much about an hour. I always have a hard time retaining people through the video. So if you're watching it now, thank you very much for sticking around. I do appreciate that. Like, subscribe, share, do all that stuff. Let me know what you think. You got any cool stories about wire ropes? I know they're really flippin' dangerous when they come apart because they hold a lot of energy wrapped up. Because when you tension them, they become like a rubber band. They shrink down. Like King Ka launch and stuff like that, if it's using a 25 millimeter cable, like a 1-inch cable, right? If it was using a 25 millimeter cable, when that thing launched, that thing probably sucked down to 20 millimeters or like 3/4 of an inch under its full load. Like that thing just went. And then if you cut them, boom, they blow apart almost like a bomb. Really bad news. Saw that one for the accelerator where that cable came apart midway down the track there and threw a bunch of shrapnel up at the people on the train. That was a bad one. Cables breaking is no good, not at all. Yeah, like, subscribe, share, do all that stuff. It does help me out. I do appreciate it. If you want to email me, you can email me, just very simple, RyanTheRideMechanic@yahoo.com. All one thing, no spaces, no nothing. RyanTheRideMechanic@yahoo.com. I think that's it. Stay off the air gates. Bye.